students, chapter 5, laws of motion. Yes, we have completed almost all theory. Now we will see some questions. Example 5.6. Mass of 6 kg is suspended by a rope of length 2 meter from ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint P of the rope as shown in figure. What is the angle the rope makes with vertical in equilibrium? Take G is equal to 10 meter per second square and neglect the mass of the rope. See what is given. You have this ceiling, one rope of length 2 meter is suspended from ceiling, and at its one end mass 6 kg, mass of 6 kg, M is equal to 6 kg is suspended by a rope of length 2 meter from a ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint P of the rope as shown in figure. At this midpoint, a horizontal force of 50 Newton F is equal to 50 Newton is applied in horizontal direction at the midpoint P of the rope as shown in figure. The question is, what is the angle the rope makes with vertical in equilibrium? See, if you apply force on this point in this direction, so yes, as this block is connected with this string, it will be in vertical plane, suspended, but this string, it will make some angle with vertical. And situation, here I will draw like this. Okay, see. It is ceiling like this. It will be like this. Okay, horizontal force F is equal to applied in this direction. Log as mass is connected, it will be in vertical plane like this. And this string, now it makes some angle with this vertical. Clear about this situation? So yes, when you apply some external force F on midpoint, in equilibrium, situation will be like this, in equilibrium, okay, equilibrium condition, okay. So yes, we have to find what is the angle the rope makes with vertical in equilibrium. So I have assumed, let it makes angle theta with vertical. It makes angle theta with vertical. Okay, so we have to find this angle theta. Okay, now we have to identify numbers of forces. Let this midpoint is named O. This midpoint is named O. Numbers of forces M. So yes, it is mg in downward direction. Yes or no? It is horizontal force, not string. Okay, yes, it is a string and it is a string. So yes, here tension is produced in this string. Let that tension is produced in this string. Let this tension is T2. And tension produced in this string, let it is T1. Let it is, clear about this? Okay, tension produced in this string, I have assumed T2. Tension produced in this string, I have assumed T1. Clear about this? Okay, now system is in equilibrium condition. It means block is in equilibrium. Block is in equilibrium. Yes or no? Yes, block is in equilibrium. So first of all, I will draw only this block. Only this block. On this block, mg is acting in downward direction. Yes or no? And if block is in equilibrium means sigma f is equal to 0. Sigma f is equal to 0. Then for equilibrium, if mg is acting in downward direction, obviously tension T2 is acting in upward direction. Tension T2 is acting in upward direction. And we know that in equilibrium condition, force acting in upward direction is equal to in downward direction. So here I can write T2 is equal to, it is mg. So T2 is equal to m. What is mass of block? It is 6 kg, and yes, you have to take value of G as 10. So T2 is equal to, it is 60 Newton. T2 is equal to, it is 60 Newton. Clear about this? So yes, first you have to find for block. First you have to find for block. Clear about this? First you have to find for block. Okay. Now as it is in, now as the system is in equilibrium, what is T2? It is 60 Newton. Now we will find equilibrium condition for point O. Now we will see equilibrium condition for point O. See how to find. Here it is. Block is in equilibrium. Yes. This point O is also in equilibrium. Point O is also in equilibrium. So see, we have to find this angle theta. Now see, it is horizontal direction and it is vertical direction. Yes or no? Yes or no? Yes. See here what I have to do. Let it is point O. Okay. This force is F in this downward direction, and here it is tension T. It is T1 and it is T2. Clear about this? Now force is acting in this direction on this point O. Yes, T1 is acting, T2 is acting in this downward direction and T1 is acting in this direction. Yes, force is applied in this direction. And again, remember case of equilibrium of particle when three forces are acting on it. Equilibrium of particle when three forces are acting on it. Yes, if F is acting in this direction, then yes, T1 and T2 they are in opposite direction. T1 and T2 they are in opposite direction. Clear about this? Now, yes, it is horizontal direction, it is vertical direction. Yes, it is vertical. We have to find this angle theta. Now, see, out of these three forces, this external force F, it is in horizontal direction. This T2, it is in vertical plane. But this T1, it is not in horizontal or vertical plane. So we have to resolve only T1. Then yes, I will resolve this T1 in two components. One in vertical direction, in vertical plane, and another in horizontal plane. As T1 is making angle theta with this component, it will become T1 cos theta, and it will become T1 sin theta. Clear about this? Again, yes, as system is in equilibrium, this point O is also in equilibrium. It is point O. Horizontal force is in this direction. Okay. T1 and T2 they are in these directions according to equilibrium of particle. Okay, out of three forces F and T2 they are in horizontal and vertical plane, so I have to resolve only T1 in two components, T1 cos theta and T1 sin theta. Clear? Now, as it is in equilibrium, yes, we know that if it is x-axis and yes, it is y-axis. Okay, so for equilibrium, sigma f is equal to 0. Sigma f is equal to 0 means sigma fx is equal to 0 and sigma fy is equal to 0. Chalo. Identify numbers of forces acting along x direction. Two forces are there. Yes, first is in this direction, F and T1 sin theta, and as shown in figure, they both are in opposite direction. So I can write T1 sin theta is equal to F. So yes, T1 sin theta is equal to, what is value of F? Yes, F, it is given 50 Newton. Clear about this? Now, sigma Fy, forces acting along y direction, T1 cos theta and T2. So yes, how can I write? Forces acting in upward direction is equal to forces acting in downward direction. So it is T1 cos theta is equal to, it is T2. T1 cos theta is equal to, it is T2. So yes, T1 cos theta is equal to T2. Yes, what is value of T2? It is 60. Clear about this? So yes, for point O in equilibrium, we can write these two equations. Now, if I am taking ratio of these two equations, that is T1 sin theta upon T1 cos theta, then I will get it is 50 upon 60. Means it is 5 by 6. So yes, tan theta is equal to, it is 5 by 6. So therefore theta is equal to tan inverse 5 by 6. Clear about this? 5 by 6. If you calculate in calculator, and then how to find angle, and then how to find angle, that we have already discussed in meeting. If you will find angle, theta is equal to nearly 40 degree. Theta is equal to nearly 40 degree. Clear about this? So yes, it is a question in which the whole system is in equilibrium. The whole system is in equilibrium. And for equilibrium, remember, sigma f is equal to 0. Sigma f is equal to 0. Sigma f is equal to 0 when system is in equilibrium. When it is in equilibrium condition. Clear about this? Again, take care about figure, how to draw such figures for block and then separately for point O. Now, second question, example 5.9. See, what is acceleration of block and trolley system shown in figure? If coefficient of kinetic friction between trolley and this surface is 0.04, find tension in string. Take G is equal to 10 meter per second square. See, this question is different. Why? In previous question, we have discussed about when system is in equilibrium, means sigma f is equal to 0. Here, you have to find acceleration of block and trolley system. Acceleration. Remember Newton's first law of motion. If there is acceleration, means there is some net force. So here, as we have to find acceleration, sigma f is not 0. Sigma f is not 0. See, here it is. Yes, mass of this trolley, it is 20 kg. And mass of this block, it is 3 kg. It is 3 kg. So first of all, I will identify force. See, M of trolley, MT, it is 20 kg. And mass of block is equal to, it is 3 kg. Okay, mu it is 0.04 given. First of all, how to draw forces? How to draw forces? See, as it is one block that is in vertical direction, okay, no contact with any surface. Clear about this? It is connected with a spring over this pulley, means it is one same string. It is one same string. It is one same string. So tension produced in this string at each and every point will be same. It is connected with this trolley. Now we know that if you are given such system, in such system, as it is on surface, trolley is given, from this pulley, one block is suspended, then we know that on this block, MBG, that is acting in downward direction, and due to that, as it is connected with trolley, this block will move in downward direction and this trolley will move in this direction with some acceleration. With some acceleration, this block will move in downward direction. This trolley will move in this direction with some acceleration. And as they are connected with a string, as they are connected by a string, they will have common acceleration. Their acceleration is common. So I have to assume that common acceleration is A. Clear about this? Again, whenever some bodies are connected with each other, their acceleration will be same. See, if there is one vehicle, with that vehicle another vehicle is connected somehow. Okay, so if acceleration of first vehicle is 10 meter per second square, then what is acceleration of second vehicle? Obviously, as it is connected, acceleration will be same. Acceleration will be same. Yes or no? Clear about this? So see here, as this block and this trolley, they are connected with the help of this string, they have common acceleration. They have common acceleration. So here I have to assume let acceleration of system is A. Let acceleration of system is A. Acceleration of system is A, that I have to find. Okay. Now forces acting on this system. It is moving in this direction. MBG is in downward direction. So let tension T, it is in this direction. Yes or no? Yes, it is. Tension is also produced in this spring. That is tension T in this direction. Now you may ask, sir, why tension in this direction? We will resolve it. See. Yes. Here this block is not in contact with any surface. So yes, there is no force. There is no friction force. But this trolley is moving on this surface, so obviously there is kinetic friction. And yes, we have assumed that this block is moving in downward direction. This trolley is moving in this direction. So yes, kinetic friction is in opposite direction of its motion. Is in opposite direction of its motion. So yes, that kinetic friction Fk, it is in this direction. That kinetic friction Fk, it is in this direction. Clear about this? Clear about this? So these are forces. These are forces acting on system. Again, see, also as this trolley is on this horizontal surface, weight of trolley in downward direction, mdg. Yes or no? And due to that, normal reaction in upward direction. Normal reaction in upward direction. So clear about this each and every forces. Again, on this block, MBG in downward direction. So yes, due to this block will move in downward direction. So acceleration is in this direction, common acceleration. Yes, this block is moving in downward direction. This string becomes tight. So yes, tension T. As it is moving in this direction, trolley, friction force, it is in opposite direction. Weight always in vertically downward direction, and here it is normal reaction. It is not in contact, so no normal force and no contact friction force. Okay. Now, see, we have to find what is acceleration and what is tension produced in the spring. First of all, I will consider this system block. Okay, block. For block, block. I will draw only block. I will draw only block. On block, in downward direction, force acting is MBG. Yes or no? And in upward direction, force acting is tension. Clear about this? Okay. And yes, it is moving with acceleration A in downward direction. It is moving with acceleration A in downward direction. As it is moving with some acceleration, here now sigma F is not 0. So how to write? How to write? Yes, sigma F is equal to block is moving, means it is mass of block with acceleration A, so with mv. Clear about this? How to write? Clear about this? Yes, it is not in equilibrium, it is moving with some acceleration, so sigma F is not equal to 0. Sigma F is equal to block is moving, so mass of block, acceleration is A, that we have assumed, so it is mva. Now sigma F means forces acting on block. Two forces are acting on block, mvg in downward direction and T in upward direction. As these two forces are in opposite direction, one I have to consider positive, another I have to consider negative. Which one to consider positive? See, this block is moving in downward direction. This block is moving in downward direction. So obviously this mvg is greater than T. This mvg is greater than T. Then how to write this sigma F? It is mvg minus T is equal to, here it is mva. Here it is mva. Clear about this? Okay. Again, draw only this block. mvg is acting in downward direction. So tension is produced in opposite direction according to Newton's law of motion. Acceleration it is in downward direction of this block. So sigma F is not equal to 0. Sigma F means forces acting on this block. Two forces are acting and in opposite direction. So one I have to consider positive, another I have to consider negative. Which one I have to consider positive? In which direction there is acceleration. Clear about this? Now put value that you know. mv, that is 3, into g means it is 10, minus t, is equal to mp. What is mass of block? What is mass of block? It is again 3, and here it is a, and here it is a. Clear about this? So yes, it is 30 minus t is equal to, here it is 3. Equation number 1. Equation number 1. Okay. Now it is for block. Now I will draw such forces again for trolley. For trolley. Then see, for trolley, how to draw such forces? How to draw such forces? I will draw here. See here, for trolley. For trolley. See, it is trolley. Okay, on this surface. Clear? Friction force, it is acting in this direction. Friction force, it is acting in this direction, that is Fa. Yes or no? Yes, it is. So tension is produced in this direction. And yes, under the effect, this block is moving with acceleration A in this direction. So yes, in this case, block is moving in horizontal direction. Sorry, trolley is moving in horizontal direction. This block is moving in vertical direction. Clear about this? Any doubt? Sure. So now, for trolley, again, I can write the same equation. This trolley is moving with some acceleration. So sigma f is not 0. Sigma f is not 0. So how to write? Sigma f is equal to mta. Why mta? Mass of trolley is mt and it is moving with acceleration a. Mass of trolley is mt and it is moving with acceleration a. So sigma f is equal to is mta. Clear about this? Now sigma f, forces acting on trolley in this direction, in direction of acceleration, along direction of acceleration, along direction of acceleration. Two forces, T and Fa. T and Fa. Yes or no? Yes or no? So yes, here two forces are acting. One is T and one is Fa. See, T and Fa, they are in opposite direction. Then how to write sigma f? Yes, it is T minus Fk is equal to, here it is mta. Why T minus Fk? Because acceleration, it is in direction of T and Fk is in opposite direction. Clear about this? So yes, it is T minus Fk. Now how to find Fk? How to find Fk? Yes, we know that. We know that Fk is equal to, it is mu k into n, is equal to mu k. What is value of n? See, what is value of n on this trolley? In downward direction it is mtg, and in this upward direction it is n, and this upward direction it is n. Clear about this? Clear about this? Yes or no? Okay, na? So yes, mtg, and here it is. Then how to write? How to write? Mu k, n I can replace by mpg, and I can replace by mpg. What is value of mu k? Yes, what is value of mu k? Mu k is equal to 0.04. Okay, mt, mass of trolley, it is 20. It is 20, and value of g, it is 10. Value of g, it is 10. Clear about this? Okay, this 0.04 means it is 4 into 10 raised to minus 2, and here it is 200. So this 20 and this 10 raised to minus 2 cut, it is only 8 Newton. It is only 8 Newton. Clear about this? How to find value of Fk? Fk is equal to mu k into n is equal to mtg, n is equal to mtg. Now put value. So it is T minus, what is value of Fk? It is n, A is equal to mt, mass of trolley, it is 20. A. It is equation number 2. See, you have to find two questions. First tension and then acceleration. Tension and acceleration. First equation, 30 minus T is equal to 3A. T and A. Second equation, T minus 8 is equal to 28. T and A. Yes, you have two variable, two equations. So math says that you can easily find such variables. How? See, it is easy. In this question number 1, see, it is 30 minus T, and this second equation T minus 8. So here T is negative and here T is positive. So yes, if we add such two equations, T will be cancelled out. So we can easily find what is value of A. So see, equation number 1 plus equation number 2. First of all, I will add left hand side. So it is 30 minus T plus T minus A. Clear about this? right hand side is equal to 3a plus 20a. So yes, this t cut. 30 minus a means it is 22 is equal to, it is 23a. So what is acceleration? It is 22 by 23 meter per second square. Meter per second square. Clear about this? Okay. And now another question: how to find tension? So yes, to find tension you can use any equation. Equation number 1 or equation number 2. Equation number 1 or equation number 2. What you have to do? You have to just put value of acceleration. You have to put just value of acceleration. For example, in this equation, from equation number 2, t minus a is equal to 20a. So t is equal to 20a plus a. Now 20. What is value of a? It is 22 divided by 23 plus a. So now this thing you can easily solve. Yes or no? Yes, you have to find what is value of t and write value of t in comment box. Yes, tension is force, so its unit will be Newton. Clear about this? So yes, in today's lecture we have discussed two questions. In first question, the system was in equilibrium, means sigma f is equal to 0. In this question, system is not in equilibrium, it is moving with some acceleration. So what are changes? What are changes that you have to differentiate? Clear about this? So yes, remember these two questions. What is difference between them? Write down, make notes, send notes, and if you have any doubt, then contact respective teachers. Plus do like, share and comment videos.